Hey guys, this is 11.1 day 3. Today we're going to continue talking about our box plots and our distributions and so on. So remember, we've been talking about quartiles, right? And this is a way that you can divide your data into 4 sections. You have Q1, median, which is Q2, Q3, and so on. What these quartiles do is once you have them in a box and whisker plot, they basically tell you where most of the data lies, right? So for example, if you take a look at this graph right here, in this first box and whisker plot, you can see that most of the data lies here, right, in between this range, right? So that's the biggest benefit of a box and whisker plot. It just by looking at it, it tells you in what range most of your data is. So now, what if you have 2 separate pieces of data, right? So for example, you're polling for a certain candidate, and let's say you're asking, men of between, 18 and 25, and you're asking women between 18 and 25, and you want a side-by-side comparison of how that data looks. Well, you can do the same exact thing. You could do box and whisker plots for 2 of them, and we call that a side-by-side comparison, right? So you can literally just draw both of them on the same set of axes, and then you can create a side-by-side summary and you can figure it out, okay? All right, so take a look at this right here. It says the number of home runs hit. So if I go back to this first one, right before I move on to example number 4, if I go back to this first one, I see that most of the data in the first one, right, is higher than the data in the second one, right? So if these were, let's say, if I was polling, men versus women, right, and if it was a certain candidate, then I could say, okay, a greater, the approval rating within men is higher for this candidate than it is for the women, and so on. All right, so now let's take a look at example number 4. The number of home runs hit in Major League Baseball in 1927 and in 2007 by the top 20 home run hitters is shown, right? So this is just the data for 1927 and then 2007. Construct side-by-side plots of the data sets, then use this display to compare the distributions. So basically what we're going to do is we're going to create a single number line just like we did before. And if you look at the data in 1927, the lowest number of home runs was a 10 and the highest was a 60, as opposed to 2007, the lowest was a 30 and the highest was a 54. So you see they're pretty much within the same range. So as far as my number line is concerned, right, what would be a good number to start? So go to the lowest between the 2 of them. That's 10, right? And remember, we always said, like, you want to make it a round number for the first data. So 10 is already a round number. So I'm going to go to 10. And now how high am I going to go? Well, let's see, the highest is 60, so I could just go up to 60, and why don't we go by 10s? 30, 40, 50, 60, okay? That is not an evenly distributed graph. What is important is that this at the bottom, it has to be just like a straight number line. The divisions, the calibrations, it would have to be like a ruler, like even generic calibrations. So 10, 20, 30, 40, 50, 60. This is irrespective of your data, right? It doesn't matter what the data looks like. This has to be calibrated evenly first, just very, very generic. Okay, now we're going to do the distributions here. I'm actually going to show you guys how to make these box plots on your calculator. So what I'm going to do is we're going to put these two pieces of data into the calculator. So I already have them right here, right? This so it's the same exact way. You open up a spreadsheet. This first one is 1927, and I've labeled it B, right? Except this is supposed to be a 14. And the second one is 2007, and I've labeled it B. Okay, now everything else is the same. So you go to Control, add a page, and we're going to add data and statistics, right? And it puts all the values here. So here, click to add a variable. When you do that, you're going to have an option of both of them. Let's just do A for now. That's what it does. Now, I'm going to go to Menu, Plot Properties, and I want to make it, Plot Type, and I want to make it a box plot. Okay, right there, that's a box plot. So now I want to do a couple of more things with this. So first of all, what I want to do is go to Menu, Plot Properties, Extend Plot Whiskers. So here you've got the whiskers. What I also want to do is I want to make this look like my own graph or my own number line. So what you can do is Menu, you can go to Window Zoom, Window Settings, and you want to make it from 10 to 60. It's not really as important to do this because what you could also do, in fact, let me just revert back to what it was before, right? They were going from 5 to 65. Okay, it really doesn't matter because what you can do is when you hover, right, it tells you that this is the minimum, it's 10, Q1 is 14, median is 16.5, and so on. And so what I can do is I could just take that one and I could plot it right here. So let's see, the minimum is 10, Q1 is 14, Q2, or the median, we said was 16.5, very, very close. And then 23. And there's the box. Okay, this literally has to be a box. Okay, and then we're going to go to 60. And you can see this is definitely right or positively skewed. And then I'm going to label this 1927. Now what you're going to do is right here, you want to add a variable. Oh, wait a minute. Let me go back here. I want to do both of them in the same one. All right, so what you want to do in order to add the second one is you want to hover somewhere in the gray area here. And then what you want to do is right click on your calculators is basically Control Menu, right? And now it says add an X variable. So Control Menu is the right click, add an X variable, and it tells you which one do you want to add. Well, I want to add B. So if you add B, do you see how it gives you that box plot right here? So now you can compare them side by side. All right, so for that one, the minimum is 30. The median, 32. I'm sorry, not the median, Q1. Q2, the median is 34. And then we have 38. And the maximum we had said was 54. That's what that looks like. All right, and you can label that one 2007. Okay, so now you can do 2 on 1, right? So now it says use this display to compare the distributions, right? Well, there is a lot of information we can gather from here, right? One is you can see how the box for 2007 is further to the right than in 1927. That means most of the scores or the home runs, right, lie within the 32 to the 38 range, whereas in 1927 it was a lot lower. So what does it tell you? It tells you that the players in 2007 hit more home runs than those in 1927. Hit more home runs in 1927 than 2007. However, this could also tell us something else. The player who hit the most home runs, that was in 1927, right? So, however, maximum runs happened in 1927. Right? So this is where you are able to compare two pieces of data. All right, let's move on to percentiles. You see this all the time. Every time you get your PSAT or SAT scores back, or whatever standardized test scores back, it tells you, okay, you scored in the 87th percentile, you scored in the 50th percentile, 90th percentile. So what does all that mean? A percentile is used to indicate the relative position of an individual with the data set. So, okay, fine. You scored, on your test, you got a 99. Fine. Or on your test, you got a 87. Where are you compared to the other people who took that test with you? All right. So, suppose you said, or suppose they told you that you are in the 87th percentile. What that means is 87% of the people who took the test with you. So suppose this was PSAT, all right? Or SAT. Suppose this is SAT and you took it in, I don't know, April, and you're in the 87th percentile. That means of all the people who took that same SAT test the same day that you did, 87% scored the same or lower than you. Right? So that's what it means if you're in the 87th percentile. And it means only 13% scored higher than you. All right? So what percentiles do is they divide a distribution into 100 equal groups, right? And we usually label them like P1, P2, P3 until P99. And then, so the percentile is, 100 minus wherever you are. We can use frequency tables to create percentile graphs. In fact, that's what we're going to do right now. So this is a frequency table right here. And look at this. We are given class boundaries here, right? And I purposely did this because I wanted you guys to recall what, boundaries and class limits and everything was. So if we go back to our previous notes, right? Remember how we had these and these were the classes, right? The class limits. We said for a class of 10 to 19 that the boundaries were 9.5 to 19.5. So now we're going backwards. If I have class boundaries of 19.5 to 29.5, I need to say, okay, that means the class goes from 20 to 29. All right. So just to recap, if you have a class boundary of 19.5 to 29.5, the class limits are 20 to 29, right? So you go to the inside. So you go one higher here, one lower there. So you have to go on the insides, right? So then this one, it would go from 59 to 61, right? And here you would go from 62 to 64, right? Inner, 65 to 67, 68 to 70, and then 71 to 73. All right. And if you just go up, you can see that like from starting at 59, all of the numbers on the left go up by 3s, and starting at 61, all of the numbers on the right go up by 3s. Okay, so here we have the frequency. So 11 people in this range, 15 in this range, and so on and so forth. What I want to create now is I want to create, first of all, the relative frequency. You guys remember how to do the relative frequency? So basically, you have to divide 11 by the total. Well, how many total scores are there? 11 plus 15 plus 15 plus 12 plus 7. That's a total of 60. So for the first one, we say 11 over 60. Well, that's 18%. This one is 15 out of 60, 25%. Next, I have 15 out of 60 again, that's 25%. And then 12 out of 60 is 20%. 7 out of 60 is 12%. Okay. The next thing I need to do is the most important. Here, I want to do the percentiles. And the percentiles are basically this. The first one is 18. It's exactly this number. The next one, you take 25 and you add it to 18 and you get 43. So that's 43%, whereas the first one was 18%. Now, next, I take this 25 and I add it to the 43 and I get 68%. Next, I take 20 and I add it to the 68 to get 88%. And finally, this is the magic stuff here. I take 12, add it here, and what do I get? 100%. And that is not a coincidence. Why not? Because when I'm at this point, right, this is 11 students out of the 60. So I've only looked at 18%. Then over here, I've now taken into account an additional 15%. So now I've looked at 43% of the data, then 68% of the data. By the time I'm here, I've counted 88% of the data, and here 100% of the data. Okay, so it looks like my graph disappeared here. Let me get that back. All right, so now we have to construct the percentile for this. All right, so this whole thing was for the heights in Mrs. Lee's class. So here we're going to put in height, and that's in inches. And then here we're going to go percentiles. Okay, my ranges start at 58 inches, right? So nobody has in this class has a height of 0 to 58 inches. That means it doesn't make sense for me to waste an entire portion of my graph for just blank data. So what I can do is you cannot, if it has an X and a Y axis, start from a number other than 0, because the fact that this is the Y axis means it's 0. But I also don't want to waste 58 spaces. So what you can do, very technical here, do a little squiggle. What that says is there was a lot of stuff there, but it was empty. So I literally tore it out of my page. And then you can start with 58 or 59 rather. Okay, 59 because that's my first class here. All right. Or you know what? I'm going to go 58 because I want to go by 2. So let's go by 58. I want to go up by 2s. So I want to go from 58 to 74 or so. So let's do 58. Okay. And then, so let me see. All right, so if that's 58, then this is 60, 62, 64, 66, 68, 70, 72, 74, right? I want to go up to 74 because that's where my data ends, at 74. These are the percentiles, and we want to go from 0 to 100. So this is 10, 20, 30, 40, 50, 60, 70, 80, 90, and then 100. Okay, so here's what we're going to do. Let's do this. Okay. The data starts from 59 and goes to 61, right? So that means how many people have a height of 58 inches? Yep, 0. So at 58, we put 0 because that's how many percent have that height. Next, you want to go to the upper class limit, 61, and that's 18%. So at 61, it's 18% right here. And then next, go to the upper here, 64, and that's 43%. So 20, 30, 40, 43%. Next, 67, 68%. So 67, 68%. 50, 60, 68%. 70, 88%. 70, 88%, right there. And then 73, 100%. Now what we want to do after we do this is you're going to connect one point to another, one point to another. It's not going to be a straight line. It could be jagged. It's cool. 1, 2, 3, 4, 5. Okay? And these are the percentages. So you see it has to be going up to 100. So what does this tell you? This tells you that 100%, right, are within 58 to 73 inches. So now that I have this, it says estimate the percentile rank a girl with a height of 68 inches would have in this distribution. So you go to 68 inches, you go up, and she would have about, we're going to estimate, and it's about 70. Oh no, it's a little bit higher, isn't it? So 68, it's about here. So it's somewhere between like 70 and 75. Okay, so it's like 75%. So that she's at a 75 percentile. Okay? Any questions? You can ask me in class, of course. So let's do something else. So what if a girl has a height of 65 inches? What's her percentile? Let's see, 65. She's here. Her percentile would be about 55%. So that would mean 55% of the girls are shorter than the 65-inch girl. All right? All right, everybody. Thank you so much. I will see you in class.